Bismillahirrahmanirrahim. Assalamualaikum everyone. In this very short video, I will explain to you about a study entitled Mesh Analysis of 2D Beam Tensile in Finite Element. Theoretically, in finite element analysis, if we observing the mesh density, it will give two possible outcomes, which is the first, if we using coarse elemental size, it will give less accuracy to the result with less computing time. In contrast, if we using fine elemental sizes, it will give high accuracy to the result. But of course, it will consuming much more computing time. Thus, the objectives of the study is to assess the increment of mesh density which performed on cantilever beam, and to investigate the effect of mesh density upon displacement and time computing of that element analysis. To pursue that objectives, the study has been conducted by using finite element analysis software with the creation of 2D cantilever beam, and some changes has been done to the mesh density, which is including 10 elements, 50 elements, and 100 elements to see the impact on the criteria of the material. And if we can see in this section of the data and analysis, the changes of the mesh density have impacting the displacement only without impacting the computing time, which is the three of the material with different mesh density are having the same duration of computing time, which is 1 second. Only different in the displacement with different value right here. Okay, through this data analysis, two declaration can be done, which is the first is the geometry of the material itself. Okay, in this study, the material are used by using two-dimensional formation, while in previous study it has been proven, or it has been shown that three-dimensional formation are much more effective to see the impact on the criteria of the material, including such as tensile performance, computing time, force load. Alright, the second reason why the mesh density are only impacting on the displacement without impacting the computing time is because the selection of the mesh density is too minimal. Okay, the best way to see the impact or the changes of the result is by adding the numbers of elemental, okay, by adding the element sizes to thousands, to billions, because it will give much more accurate to the result. Okay, so as the conclusion, the mesh density are influencing the displacement formation. I can say that by adding the mesh density in finite element analysis of this 2D cantilever beam material, it will determine the increment or decrement of the displacement value while pursuing the simulation of FEA. Okay. This is some examples of uh, finite element method that have been done in another field in textile. Is mesh analysis of vehicle compartment in automotive textile, mesh analysis of joint system in medical textile, alright, and finally mesh analysis of slope stability in geotextile, which is show that FEA have been widely used in textile application because it gives